First things first, I'ma say all the words inside my head. I'm fired up and tired of the way that things have been. Oh, ooh, the way that things have been. Oh, ooh. Second thing second, don't you tell me what you think that I can be. I'm the one at the same, I'm the master of my sea. Oh, ooh, the master.
Arduino is one of the most common and popular open source computer hardware and software company that excels in designing and manufacturing of microcontroller based kits for building digital devices and interactive objects that can utilize sensors, control output devices and run programs designed by the user. Arduino can be used in numerous applications as it is convenient to use. The Arduino can be used to develop standalone interactive objects, or it can be connected to a computer to retrieve or send the Arduino and then act on that data like send sensor data to the internet. For this project, we reviewed several projects that use Arduino as a problem-solving medium to help people with their everyday life by making everyday tasks autonomous, which makes their life easier and more convenient. We choose to build a speed detector as it can be used to keep the vehicles in check, especially in neighborhoods and places near parks or schools without the presence of a police officer, and thus can create a self-sustaining system for regulating the road laws. There are definite guidelines on driving vehicles on roads laid down by the authorities. The most common rule in every country is the speed limit on some roads where if your vehicle speed reaches this limit, you will be in breach of the law. Patrol officers typically rely on a handheld gun that operates on radar technology or LiDAR technology to detect the speed of a moving vehicle. This is a lengthy procedure because for each vehicle, the officer must manually search for overspeeding. In the Arduino Vehicle Speed Detector project, a simple automatic speed detection of a vehicle is built where you can position the device in one place and display the results instantly without any human interference. Arduino Uno R3 segment code into functions allow the users to create modular pieces of code that perform a defined task. IR sensors to send signal input to the Arduino for the direction movement of the robot. LCD screen using a 16:2 LCD display model to display the output. Potentiometer to control the contrast and brightness of the LCD screen. ATmega 328P. ATmega 328P is commonly used in many projects and autonomous systems where a simple, low-powered, low-cost microcontroller is needed. The breadboard, the board on which electronic pieces are connected. It is the essential of any circuit making. Power supply, to provide power supply input for the whole system. For this project, we will use the 5-volt battery. Jumper wire allows electric current to travel from one point to another. This is the circuit diagram.
The objective of this project is to design and build a vehicle speed detector circuit using Arduino UNO and IR sensor. This Arduino speed detector can be used to capture speed of vehicle without any human interaction and can be also used as traffic logger or traffic counter.
For my part, I am going to explain the working principle of the vehicle speed detector. For this, optical infrared sensors are used with the photodiode receivers to form a reflective style of infrared sensor. It emits infrared radiations continuously. If there is no object in front of the sensor, none of the infrared radiations are reflected back, and if there is an object in front of the sensor, The infrared radiations would be reflected back where they would fall on the photodiode receiver, thus which confirms that an object has passed by. Using the information collected, we can also detect the speed of the object passing by.
As for the conclusion that we can conclude from this project is that the working of the Arduino based vehicle speed detector project is very simple. Inputs from the IR sensors are read continuously by Arduino. When the first sensor is hit by a vehicle driving in front of the setup, Arduino becomes alert and captures a timestamp at the moment the vehicle leaves the first IR sensor. When a vehicle hits the second IR sensor, another timestamp is registered. Arduino then calculates the velocity by assuming that the distance between the two IR sensors is 5 meters and shows the result on the 16:2 LCD monitor in kilometers per hour.